Welcome back. We are going to talk about something called the East Pacific Rise. Remember the Pacific Ocean, the Pacific Plate? It's basically, follow my outline here. You can see that's basically it. And it comes down here and comes like this. Okay? It's massive. And as I mentioned before, it's not very stable. Now, most people, when you're taught plate tectonics, you're taught about Pangea and the plates fitting together in this nice thing, and then they split apart. And that did happen. Okay, and you're shown the mid-Atlantic ridge, and you're shown like magma convections coming up from the mantle, pushing this stuff apart. Well, we've got that does happen, but that's not the major driving force. The major driving force is probably something called slab pull, which is a plate getting old and heavy, an ocean plate where it's really old, and basically cracking the crust and starting to subduct. That convection helps it along, and then you get ridge push. Now, usually, continents will rift, start to split apart on the continents. Okay? We're going to talk about this later, but you have a massive failed rift right here called the Mid-Continent Rift System. And it's a rift. It's not what we call an allocogen like the St. Lawrence Rift, which is a failed arm of a rift. It's not the same thing. We'll talk about that some other time. But I just wanted to mention it because that's what happens. But then every once in a while, you get this rift that forms in the ocean. And that can happen. And you can see here, you see this here? The plates are moving apart here. North America is moving this way relative, and the Pacific plate is moving this way. This plate used to be huge, and it's been almost consumed. I'll talk about that here in a second. That may seem odd to you, but not a plate being consumed, but what I'm going to talk about here in a second. And then you have a transform fault here. There's one here too. It's just this one goes upon the continent, so we think of it, and that's where you hear all the San Andreas fault, and oh my God, the big one's going to come, which is BS, and all that other stuff. And, California is going to end up here, which it won't. But anyway, that aside, it comes down here, that's the other transfer, and you see it here, it's rifting again. This is called the East, it's not very visible here, I don't know why. This is called the East Pacific Rise, and it continues until it meets the Antarctica plate, which is, I believe the ridge is right around here. Or no, I think it's up here. Anyway, it doesn't matter, we're not going to talk about that right now. We're just going to talk about the East Pacific Rise. And this rift here, that right here, here and here, coming down this way, that spreading is about 3 times faster than it is at the Mid-Atlantic Ridge. But the rift is getting subducted. Yes, you can subduct a rift. I know that sounds odd, but it happens. All right? So we already have a kind of issue here with that. As this rift is getting subducted and it's spreading far faster than this, you would think it wouldn't, but it is. We can measure plate motions. Something has started to happen. First, we have the Yellowstone caldera. All right, Yellowstone. You come in here. Oh, how could I have forgotten? And this is the caldera, and don't worry, it's not going to blow up in one big massive eruption and kill us all. As a matter of fact, super eruptions with it are probably dead. They're not going to happen. Even if they do, the magma chambers, there's 2 main ones. One's only like 5% full, and the other one's 15. So it's not going to happen anytime in your lifetime, or even your great-great-great-great-great-great-grandkids' lifetime. There has to be something really funky for that to happen. But anyway, that's aside. But if you look here, you'll see this topography here. This is the path of the Yellowstone caldera as North America has moved. This is a hot spot. Hot spots tend not to move. We have another one here in the middle of the ocean. They don't have to be on the continent. It's Hawaii. This whole island chain is because the Pacific plate moves over this hot spot. And the island is created, then the plate moves and gets eroded, more eroded, and sometimes it wasn't as active as others, and the islands eventually go away. Anyway, But we used to think Yellowstone was about the same age as the Hawaiian one. But now we think it might be 50 million years old. And it's right where it sits is in an unusual place, okay? Because we have this plate with a rift being subducted. We have the, this little bit right here is all that's left. But if North America keeps going to the west, it's going to go over this entire rift. And a couple of things can happen. And the Earth has been giving us clues as to which one it might be leading to. But it could not be. We have the basin and range here. This is the Colorado Plateau, the basin and range. You see this topography here. This is the beginning of a rift. I personally think it will continue. I think it's in an inactive period right now. I mean, it still erupts. There's little cinder cones over here, and there was one that erupted when the natives were around, and it was so slow though they just kind of got up and left. So it's trying to split here, the continent. All right, and if you notice, it comes right up or real close to Yellowstone, and we got this spreading center here. So we got a spreading center trying to form here. We have a hot spot here, and this spreading center being consumed. To me, that means one thing. That means the continent's eventually going to split. North America is going to fracture a big chunk of itself off. And I actually do have an animation for that, but it's for another time. All right? So this is our first one, the East Pacific Rise. And I want you to know that all rifts are not created equal. There's subduction, obviously, all over here. Some places it's easier to see. But basically, we have that's the only place in the Pacific Ocean where rifting is occurring. Everywhere else around the Pacific Ocean is subduction. Why? Because we have rifting around the entire Antarctic continent, which may seem weird because if it's rifting and the Earth isn't getting any bigger, where's the subduction? And we'll address that later. It's forming right here, but it's going to take a while. That is subduction there. There's subduction up South America. The Caribbean's a very complex thing we're going to address eventually. There's subduction there. But here's the Mid-Atlantic Ridge, and that's where everyone knows. That's where Iceland sits upon and everybody likes because it's textbook plate tectonics going on right there. And you can see it's very well defined. The rift right here, and then here's the transform faults. That's, you see, look here, you see the rift here. That's where the plates are spreading apart relative to one another. And then it comes to this, and then starts again over here. This is a transform fault, a strike slip fault. We call them on smaller scales. But basically, this part, see here's the transform fault here. This big part is moving to the left of the screen relative to this bottom part moving to the right of the screen, while this is splitting down the middle. That is completely normal, and that happens because of compensations. We like to think that there's about a dozen or so major plates on the planet, and it's very rigid, and it is. But our plates have to compensate. That's part of the reason why you get earthquakes in the middle of no known really tectonically active areas, like in northern Illinois or eastern Illinois. We're not going to talk about New Madrid. That actually is there for other reasons. So, as you know, because even though we sit there and we'll take an average and say this rift is moving 2 centimeters a year. You know, the North American plate is moving away from the African plate 2 centimeters away or from each other. That's from some sort of reference point. We'll talk about that some other time. But it's not equal all over the whole thing. So as that happens, there'll be stresses further within the plate that will buckle or stretch, and it's going to have to compensate. And there are such things as microplates, but they are part of bigger plates, all right? So I think that's it for the East Pacific Rise. I just want you to know that this baby is big and it's going to do something in conjunction with Yellowstone. and with the basin and range. And all this going on right now is why we have the Colorado Plateau. All right, the Colorado Plateau is an area rising up, but not like a mountain range. Mountain ranges usually form when you have a subduction zone here. You can have continent upon continent, but the continents are going to meet like in India and eventually stop. It's just going to shut off. But when an ocean plate, it subducts under a continent, the continent just moves across it. And that creates mountains, like on the western side of North America and South America. Okay? You know, that's what happens. But you can get mountains in other ways. All are tectonic in origin, but you can get mountains from rifting here, and you can get high plateaus where the whole area lifts up and not just or not just pieces here and then pieces there, you know, crumpling and getting a mountain range from compression. There's no compression in the Colorado Plateau. Okay, it has to do with the mantle, and there's a good paper on it, and we pretty much, it's so weird, we come back to these old concepts every once in a while, and they seem to work out. We're going back to an old explanation for the Colorado Plateau. They just didn't have a mechanism. A lot of times, these 19th and early 20th century guys had great ideas for why these things exist, they just had no mechanism. And now plate tectonics comes along and answers a whole lot of that. But, you know, you can get plateaus that just kind of evenly rise up. And big ones like the Colorado Plateau or the Tibetan Plateau. You don't need to get a crumply mountain range, all right? But those happen in areas where there's no subduction. They happen on continental interiors, usually around the leading edges of mountains, okay? Like the Tibetan Plateau is the same way. You know, up here, okay, and India, this is continent on continent collision, and the subduction was here. India moved away from Antarctica. You can clearly see it here, and they are still rising, and these two are still pushing into one another, but Asia's not going to get out of the way and make room for India, so it's going to stop eventually, and probably within the next couple million years. But anyway, that's it. If you guys have any questions or comments, please leave them below, and I hope you learned something.